Okay, so if we look at this graph, right? So this is a graph of a sinusoidal function, and you can see that it goes from negative 2 pi all the way to 4 pi. And so we want to use this graph to determine what the function looks like. So we want to use the graph of the sinusoidal function to write the function. Okay, so let's do that. Okay, so now, what do we see? Okay, well, the first thing is we can see that it's shifted down, right? Okay, because we can see that, it's shifted up, right? So first of all we see where the maximum and minimum values are. So the maximum value, right? So the maximum value that the function takes is 1. The minimum value that the function takes from the graph is 0. And so we can see that the midline, the midline, which is again equal to what? It's 1/2 the absolute value of max minus min, right? So in this case, it's going to be what? It's going to be 1/2 of 1, so the midline is going to be at y equals to half. Which you can see that from the graph, okay? Now, if we look at to find the period, we see that if we start at the 0, the period is 2 pi. Because if we start in a valley and we go until we get to the next valley, we go from 0 to 2 pi, and we end up right back where we started from. Okay, so we find that the period is 2 pi. And what about the amplitude? Well, the amplitude is what? Well, the amplitude is the distance from the midline to the maximum point. So the amplitude in this case is 1/2, right? And what else can we see from this? Let's see here. Okay, well, let's do this. So we've got, it's either going to be sine or cosine, right? So we've got y equals a sine bx minus c plus d, right? Or we've got y equals a cosine bx minus c plus d. Now, if we look at it, we can definitely see that this is going to be shifted. There's definitely a horizontal shift to this, right? So let's see what we can put here. So A is going to be 1/2. Right? So we know A is 1/2. And the midline is at 1/2, so we know that there's a vertical shift. Or no. So the midline is at 1/2. So we know D is 1/2. Right? Now, since the period is 2 pi, what does that tell us? Now the thing is notice that on the function that at the extreme point, when x is 0, we're at an extreme point, right? When x is 0, we're at a valley. Okay, so even though we could use sine, let's use cosine because it's going to be simpler. Right? We can also use the sine, but let's use cosine because since the 0 meets at a maximum or minimum value, right? Because normally sine goes through the origin at 0, right? So let's do that. So let's eliminate using that one because of that fact. Okay, now, what about the other values? Well, we found D, right? And we found A. And since the period is 2 pi, well, that's going to tell me what? Well, that tells me, remember, 2 pi, it's going to be 2 pi over the absolute value of B. Well, that tells me B has to be equal to 1, right? That tells me that B equals 1. So that tells me that I can just have this. And, well, since the period is 2 pi, and it's going through an extreme value at 0, well then C is, that's going to tell me that C is 0. So then this becomes just x plus a half. Now, the last thing is this. So if you look at the graph, it's doing this. Right? From 0 to 1. Well, a cosine curve does this. So it seems like this has been inverted, right? It's flipped, right? So it looks like it's been reflected across the x-axis. Well, how do you reflect it across the x-axis? Well, by whether a is negative or positive. Remember, the general function a. Well, I'm going to use cosine since we're using cosine. So a cosine x, right? Whether a is positive or negative tells us whether it's a reflection across the x-axis, right? Because remember, this affects y. So if this is negative, you're taking all the positive y values, making them negative, and all the negative y values and making them positive. So it's a reflection, so this becomes this. So that means this is going to be negative. And this then describes the graph we were looking at. And again, go back and look at the graph. Even after this, go back and visualize the graph and see if you could do it on your own. Okay, and see if you see that. Okay. Have a great day.